Good evening. So today you're going to find the length of an arc or the length of a curve. It's an application for integration, and we have a question here. Find the length of the curve x is equals to 5 into 2t minus sine 2t, and y is equals to 10 sine squared t between t is equals to 0 and t is equals to pi. Our formula for getting the length of a curve is going to be s, the integral from a to b, 1 plus dy over dx squared dx. So we are going to go straight into it. It's a parametric equation. Our first step is we get dx dt, and to get dx dt we need to differentiate our value of x. So to differentiate our value of x, we're going to have 10 into 1 into t minus into 1, because when you differentiate t gives you 1. You're going to have 10 into 1 minus cos 2t. That's the x dt. That's the same as 5. We factorize 5 into 2 minus 2 cos 2 cos t. We are applying the rules and the trigonometric values. Next, we're going to have dy dt. When we differentiate y, we will get 20 sin t cos t, but we know that sin t cos t is the same as sin 2t over 2, and now that gives us 10 sin 2t. And once we have 10 sin 2t, we have simplified 10 sin 2t. We are going to have the x squared, the x dt squared, plus dy dt squared. Remember, we are using parametric equations, but if it was a standard length of a curve which is not a parametric equation, our formula is just above here, the one we have said, the integral from a to b, 1 plus dy. But in our case we have a parametric equation, so we have to apply the formula for the parametric equations. But already we have the x dt, we already have dy dt, so our work is to square. When we square the x dt, we are going to have, let's just write beside it, we are going to have 100 into 1 minus 2 cos 2t plus cos squared 2t. We are going ahead to square dt, dx dt, and adding dy dt squared, and dy dt squared will give us 100 sin squared 2t in brackets. We can see that 100 is common for both. We are going to factor into 1 minus 2 cos 2t plus cos squared 2t plus sin squared 2t. From our trigonometric functions, we know that cos squared x plus sin squared y gives us 1. So this equation here, sin squared 2t plus cos squared 2t, is going to give us a 1. And now we will be left with 100 into 1 minus 2 cos 2t as our value. Moving forward, we will have and remember we have 100, so we'll have 100 minus 2 cos 2t, we are having plus 1, so we have cos 2t. We will write cos 2t plus 1 into brackets. Let's just expand our board once more. So we have plus cos 2t plus 1. 1 plus 1 gives us 2. So we will have 100 into 2 minus 2 cos 2t, of which we can factorize to get 200 into 1 minus cos 2t. We will go ahead and replace back into our function, because our formula states that, our question states that we need to find the area, the length of the curve. When you're using the double angles, cos 2t is the same as 1 minus 2 sin t squared. When we substitute back into our cos t, we will get 200 into 1 minus 2 sin squared t. When you expand here, we will get 200 into 2 sin squared t, which will be equals to 400 sin squared t. But in our formula, we need to use the square root, so we're going to get the square root of 400 sin squared gives us 200 sin t, and then we get the integral from a to b, but our a to b is pi and 0. 200 sin t, not 200 really, but 20 sin t dt, which will give us minus 20 cos t. And now we are replacing from pi to 0, which will give us negative 20 into negative 1 minus 1, and that we get that the length is 40 units. The length of our curve is 40 units. Now that's how we get the length of the curve. Thank you. Kindly remember to subscribe, like, and turn on the notification to be notified of any new video. Bye.